Okay, I think you're going to find that section 1.2.1 is a lot of stuff that you already know, but we're going to go through it anyway. So, plotting points on a rectangular coordinate system, mathematician Rene Descartes, 1597 to 1650, was the first to identify points in a plane by a pair of coordinates. He did this by intersecting two perpendicular number lines with the point of intersection called the origin. So the origin is 0, 0. These lines form a rectangular coordinate system, also known in his honor as the Cartesian coordinate system, or simply a coordinate plane. The horizontal line is the x-axis and the vertical line is the y-axis. The x and y-axes divide the plane into 4 quadrants, counterclockwise, 1, 2, 3, 4. And the quadrants, yeah. Okay, so remember that when you're plotting points, the first number is the x-coordinate and the second number is the y-coordinate. This number tells you how far right or left to go, and this number tells you how far up or down you go. So 2 to the right and 3 up is going to be right here. Negative 4, 6, you're going to start at 0, 0, and you're going to go 4 to the left and 6 up here somewhere. That's the basic idea. I think you get it. And so we'll move on. All right, distance formula. The distance formula tells you how far apart 2 points are. And this is basically just the Pythagorean theorem, because if you're trying to find the distance between the 0.15 and the 0.49, for example, you can draw a right triangle so that you know what the legs are, because if x is 1 here and x is 4 here, then 4 minus 1 is going to give you 3. And then the vertical leg of the triangle, if this is 5 and this is 9, going from 5 to 9 is 4 spaces. So you've got this you've got this triangle with legs 3 and 4. So you know that the hypotenuse, which is the distance between the 2 points, so 3 squared plus 4 squared equals d squared. So 9 plus 16 equals d squared. So 25 equals d squared. And so 5 is the distance between those 2 points. And using that Pythagorean theorem, we can write a formula for distance between 2 points. And that is just d equals the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. That's just exactly what we just did. So if you want to find the distance between these points, negative 3, 4, and 3, 0, give the exact distance and an approximation to 2 decimal places. So square root of the difference in the x's, so 3 minus negative 3, quantity squared, plus the difference in the y-coordinates, negative 4 minus 0 squared. That's going to be your distance between those 2 points. So you've got the square root of 3 plus 3, which is 6, squared is 36, plus negative 4 squared is 16. So you've got the square root of 52, and you can reduce that square root because 4 goes into 52 13 times. So you're going to have the square root of 4 times 13, which is 2 square root of 13. So that would be the exact answer. And then if you punch that into your calculator, 2 times 13 square root equals, you're going to get about 7.21 for your answer. Here's another example. Find the distance between the points negative 1.2, 4.5, and 3.8, 1.5. Give the exact distance and an approximation to 2 decimal places. So again, you're going to use the distance formula, square root of the difference in the x's, negative 1.2 minus 3.8 squared, plus the difference in the y's, 4.5 minus 1.5 squared. You get 25, and then 4.5 minus 1.5 is 3, so that would be 9 when you square it. So you're going to have the square root of 34, and 34 is 17 times 2, so you can't reduce that. That's the exact answer. And then if you punch that into your calculator, 34 square root that is going to be about 5.83. So you want to determine if the given points form the vertices of a right triangle. You got negative 2, 1, 2, 5, and 5, 2. And that triangle kind of looks like a right triangle. It could be. It definitely looks like it is. But we're going to use the distance formula to figure that out. So we're going to find the distance between all the points. So for A, the distance from A to B, and I'll just write that as distance AB, is equal to the square root of negative 2 minus 2 quantity squared plus 1 minus 5 quantity squared. And that's going to be the square root of 4 squared, which is 16, plus negative 4 squared, which is 16. That's going to be the square root of 32, which is 4 square root of 2. And then we'll look at the distance from B to C. Well, hang on, let me just write that in. 4 square root of 2 over here, from A to B right here. So 4 square root of 2. And then the distance from B to C, let me just mark these. So this is A, this is B, and this is C. So the distance from B to C is going to be the square root of 2 minus 5 squared, which is 9, plus 5 minus 2 squared, which is 3 squared, which is 9. So you're going to have the square root of 18, which is equal to 3 times the square root of 2. So B to C is 3 square root of 2. And then the distance from A to C is going to be the square root of negative 2 minus 5 is negative 7, so 49. And then 1 minus 2 is negative 1, so square it, that is 1, so square root of 50. And that is equal to 5 times the square root of 2. So 5 square root of 2. So we're going to see if this is a right triangle by using the Pythagorean theorem. We can see that 5 square root of 2 is the longest side, so that would be the hypotenuse. So 4 times the square root of 2 squared plus 3 times the square root of 2 squared should equal, if it's a right triangle, 5 square root of 2 squared. So that's 16 times 2 is 32, plus 9 times 2 is 18. Does that equal 25 times 2, which is 50? And it does. So yes, it is a right triangle. Yes. Okay, the midpoint formula. To find the midpoint of any segment, all you have to do is take the average of the x's and the average of the y's, and that will be the midpoint. So it's pretty simple. Find the midpoint of the line segment with endpoints negative 1.8, negative 3, and 4.5, negative 1. So we just add the x's and divide by 2. Add the y's and divide by 2. And that is going to give us 1.35 for x and negative 2 for y. And that is the midpoint. Plotting points is not the best way to graph equations. You're going to start learning how to recognize different graphs just by looking at the equation, but it's the way you start out. So when you want, like if you want to graph this line right here, you can set up a chart with x and y, and you can pick some values for x and see what you get for y. So we might start with 0 for x, and if you plug that into the equation, you're going to have y equals 0 plus 2, so y would be 2 when x is 0. If you look at x at negative 4, for example, you could plug that in and you would have y equals negative 4 plus 2, which gives you a y value of negative 2. And then maybe if you chose 2 for x and plug that in, you would have y equals 2 plus 2, which is 4. And so you can see these points are graphed, and then if you connect those points, you get a line. So plotting points to graph an equation. Let's look at some more, slightly more complicated equations. Now this equation is a parabola. I already know that. You may not know that yet because you may not recognize the graph of a parabola, but we're going to learn that. But if you started to just pick some points for x or pick some numbers for x and y and see what you get. So if you choose 0 for x and look at y, that would be 0 plus 3. So that would be 3. So that's going to be 0, 3. And you could graph that right here. And then you could pick something like 1 for x, and you would get 1 plus 3, which is 4. So the point 1, 4 is on this graph. 1, 4. And then you could try 2. 2 squared is 4 plus 3 is 7. So 2, 7. So you can already see that this is not a line because those points don't line up. And now it might be a good idea to choose some negative values. So you could try -1, and that would give you y equals -1 squared, which is 1 plus 3 is 4. So -1, 4. And that is going to be right here. And then you might try -2. So if you plug that in, you're going to get 4 plus 3, which is 7. So -2, 7 is on this graph. And so you can see that that's a mirror image on either side. And if you were to graph that, it would be a parabola. Now we're going to graph y equals the square root of x plus 3. So again, you can start at 0 for x. And you're going to get that y is the square root of 3. So 0 square root of 3. And the square root of 3 is about 1.7. So it'd be right here. And then you might try 1 for x, and that would give you square root of 1 plus 3, which is 4, so 2. So 0.12. Sometimes it's a good idea to choose values that give you a perfect square in this case. So I would go ahead and use -2. So that would give me the square root of -2 plus 3, which is square root of 1. That'd be 1. So -2, 1 is on this graph right here. And then you could use, now if you try -3, of course, you're going to get the square root of 0, which is 0. So -3, 0 would be right here. And if you try to go any further left on the x-axis, you're going to get a negative value. So you know that this is a function that the x values have to be -3 or greater. So now you can see that this is a curve that it has to stay above the x-axis. There's no way to get a negative value for y because you can't have a negative value inside the square root in the real numbers. So that is actually kind of a half of a sideways parabola. Because if you square both sides of this equation, you get y squared equals x plus 3. So it looks a lot like the one we had that had an x squared in it. But it is flipped sideways. So, okay, so now you want to graph the equation, x squared plus y equals 4. Sometimes it's easier to just rewrite the equation with y isolated. So you'd have y equals -x squared plus 4. And you could set up your little chart. And if you choose 0 for x, y is going to be 4. And then if you choose 1 for x, you're going to have -1 plus 4, which is 3. So 1, 3 is on there. If you try 2 for x, you're going to have -4 plus 4, which is 0. So that's right there. You could try -1 for x, and if you do that, you're just going to get the same thing you got for 1, which is 3. And then you could try -2 for x, and you would get the same thing you got for +2, which is 0. So again, you've got this parabola, except now it's upside down. So that is what you get. All right, one more. Graph the equation by plotting points. X minus y squared plus 2 equals 0. So again, if you wanted to, you could go ahead and isolate y. So you would move the negative y squared to the right side, and you have y squared. And then you've got on this side x plus 2. So that would mean that y would equal the square root of x plus 2, plus or minus. If you try that, if you put in 0 for x, that's not going to be too fun. So let's try something different. Let's try -2 for x. We put in -2 for x, we're going to get the square root of 0. So y is going to be 0. -2, 0, which would be right here. And then if you try -1 for x, you're going to get the square root of 1. So that is going to be 1. So -1, 1. And since it is plus or minus, we know that -1 is also going to be on this graph. If you try 2 for x, put that in, you're going to get the square root of 4 plus or minus, which is plus or minus 2. So you would have 2, 2, or 2, -2 are both on this graph. So 2, 2 right here, and 2, -2 is right here. So you can see that you have this sideways parabola for this one. So that is how you would plot that one. Now, identifying the x and y intercepts. When you cross the x-axis, your y is 0, and when you cross the y-axis, your x is 0. So when you're trying to find the x and y intercepts, you just put in 0 for x and 0 for y and see what you get. And so here's what I just said. You find the x-intercepts by substituting 0 for y. You find the y-intercepts by substituting 0 for x. So estimate the x and y intercepts from the graph. So if you look at the graph, it looks like the x-intercept is going to be 0. So 3, 0. And it looks like it crosses the y-axis at 0, 3. And this one, if you look at the x-intercepts, it looks like it crosses the x-axis at 2, 0 and -2, 0. So this one has two x-intercepts, 2, 0 and -2, 0. And then the y-intercept is down here where it crosses the y-axis, so that is 0, -4. Now we're going to look at the equation and find the x and y intercepts. So for this equation, I'm just going to go ahead and get y by itself. So if you put in 0 for x, you get y equals 9. So 0, 9 is your y-intercept. So for your x-intercept, you're going to put in 0 for y. And when you do that, you're going to get 0 equals x squared plus 9, which means that x squared would have to equal -9, which is not possible. So this graph does not cross the x-axis. Okay, for this one, you have x equals the absolute value of y minus 3 plus 2. So to find the intercepts, the y-intercept is going to happen when x equals 0. So we would have 0 equals the absolute value of y minus 3 plus 2. And so that would mean that the absolute value of y minus 3 would have to be -2. And we know that's impossible. An absolute value cannot be negative. So this does not cross the y-axis. The x-intercept is when y is 0. So if we put in 0 for y, we're going to get x equals the absolute value of 0 minus 3, which is the absolute value of -3, plus 2, which is 3 plus 2, which is 5. So your x-intercept is going to be 5, 0. Okay, here you want to find the x and y intercept. For your y-intercept, you're going to put in 0 for x. So let's see what happens. You'll have 0 over 9 plus y plus 3 quantity squared over 4 equals 1. So you have y plus 3 quantity squared over 4 equals 1. So y plus 3 quantity squared equals 4. Let's take square root on both sides. Y plus 3 is equal to plus or minus the square root of 4, which is plus or minus 2. And so that's going to happen when, okay, so that's going to mean that y is equal to negative 3 plus or minus 2. So that means there are two y-intercepts. Negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So it's going to cross the axis at those two places. So when you put in 0 for y, you're going to have x squared over 9 plus 0 plus 3 squared, which is 9, over 4, and that's supposed to equal 1. So you'll have x squared over 9. If you subtract 9/4 on both sides, you'll have 4/4 minus 9/4 is negative 5/4. And so if you cross multiply, you'll have 4x squared equals negative 45, and that's impossible because x squared is positive and 4 is positive, so you can't get a negative number for that. And actually, we could have seen that here already. So this does not cross the x-axis.